Next section is just piggybacking off of what we did on Monday with the area formulas. So we do want to remember the formulas, length times width for rectangle or square, base times height for a parallelogram, 1/2 base times height for a triangle, and then pi r squared for a circle. Because what we're going to have is these complex shapes where they're actually two shapes made into one, or on the back, a shape missing a shape, okay? So whenever we have two shapes added into one, we're just going to use addition, okay? Say this is the area of maybe your yard, all right? And you need to know how much fertilizer you need to fertilize your grass or something. So what we want to do is we want to find the area of this part, but what shape is this? Has anybody taken geometry where they do these tick marks, what those tick marks mean? They're equal, exactly. So anytime you have a shape where the tick marks match, so for example, these have single tick marks, so that means this is the same as well, so we could do a tick mark there, and we could do a tick mark there, right? So when you do a single tick mark, it means every place we put a tick mark, it's the same side. Notice these two sides are not the same, but they're the same to each other. So if you wanted to, you could put two tick marks. We don't have to, but that's just kind of a little side note from geometry, okay? So these just mean these are equivalent. Anyway, so what shape is this if all the sides are the same? A square. So do you guys agree that we're going to have the area of the square plus the area of this shape? What's this shape when it looks like a rectangle that's been smushed? Parallelogram. So we're going to have the area of a parallelogram. So what we can do is just figure out the area of one, figure out the area of the second, and then add them together because that's the total yard together. So what's the area of a square? Technically, its formula is s squared, side squared, s times s. I still use length times width. I don't care what you say. A square is just a special rectangle, right? And then what was the area of a parallelogram? Kind of the same thing, but they use base times height. All right? So what we have to do is we have to do some investigating. Notice that the parallelogram is the only thing that's been labeled. Its base is 3 and its height is 5, okay? So we can fill in this part over here. Its base is 3, based on that, and its height is 5. Remember, it's where that right angle's made. But notice what we did with our tick marks, right? We said this side was the same as this side, which is the same as all these sides. So if this is 3 centimeters, what is this? 3 centimeters. And what is this? 3 centimeters. And we could keep going. Do we need to keep labeling all of it? No. If you're doing perimeter and you're adding up all the sides, you'll want to label all of it. But for area, you just need one side and one side, right? So length times width, consider this the length, that's 3. Consider this the width, that's 3. So the square is just the side squared, right? 3 squared, or 9. And the parallelogram is just base times height, or 15. Does that look right so far, guys? So our final answer when you add the two is 24, but just, again, don't forget about our units squared. So maybe this is a yard for ants. I don't know. They're only centimeters, okay? Anybody, you guys are way too young. None of my jokes make sense anymore, but does anybody watch Zoolander way back in the day? What is this? The school for ants, right? What is this? A yard for ants? Here, guys, say this is maybe you live in a house where the top floor kind of has like that attic feel. So this is a wall you need to paint, okay? So the wall's not a perfect rectangle because the attic has these cool vaulted ceilings. So what is the area of this wall in order for us to find how much paint we need? So this one's the easy one. What shape is this down here? A rectangle. But what shape is this when you have two parallel sides but the other ones are oblique to each other? Trapezoid, right? So try your best to draw a little trapezoid here so we know what we're talking there. And again, I'm just showing you that this wall is made up of two shapes, right? The trapezoid on top and the rectangle on the bottom. And if we can find the areas of both and add them, then we have the area of the entire wall. So the trapezoid is one that I would not think that you guys would have memorized at all. You don't have to memorize any of them, but you know, we've done base times height a lot of times. The trapezoid, if you remember, was 1/2 B1 plus B2. So this was 1/2 base 1 plus base 2, and then times the height. And remember, the whole idea there was the 1/2 B1 plus B2 was averaging the bases, right? And then we average the bases and still multiply by that height. And then what was the formula for the area of a rectangle? Just length times width. All right, so we're just going to fill everything in. 1/2 is part of the formula, so it's going to stay a 1/2. It really doesn't matter which one's base 1 or base 2. Typically, you make the smaller one base 1, but that does not matter. So we'll just put 6 there. And then this is just kind of like what we did above. What do we know about a rectangle? We know that the rectangle has opposite sides that are equal, correct? So this side of 10 kilometers is the same as this side. So what is base 2? 10 kilometers. Are you guys okay with that? So they don't label everything exactly. So B2 is 10. Because B2 goes along this base down here, which is the same as the base of that rectangle. All right. We can't forget that this is just averaging the bases. We still need to multiply by our height, but remember your height is always what makes that right angle. The height is 4. All right, the rectangle is the easy one. Length, which is 10, times width, which is 5. All right, so I heard some calculators are already kind of going. What do you guys get for the trapezoid when you do this? And a lot of us can even just do it in our head if we do order of operations, right? 6 plus 10 is 16, but what's half of 16? 8, and what's 8 times 4? 32. Did you guys get 32, those that did it in your calculator? So that's 32. And then 10 times 5 is just 50. So the total area of this wall is 80 kilometers squared. And obviously that's not in our house since it's kilometers. Maybe it was 80 feet or something. That'll be a little bit more realistic. But 82. Oh, 82. I cannot do math. Sorry. You are correct there. So the 32 would add a 2 there. Absolutely. Perfect, guys. Thank you. All right. So this next one, there's 2 ways to kind of look at it, and you go with what you see. And so that's why I want you to realize when I teach it, I might see it one way, and then you see it a different way, but it doesn't mean we're wrong. Do you guys agree that these are just 2 rectangles kind of butted up to each other? The question is, do you see this rectangle butted up to this rectangle? Anybody see it that direction? Yeah? Or do you see that rectangle butted up to that right? You see how I'm talking about? Either way we have to do a little bit of math, okay? It's not going to be easy either way. And I'll just leave it like that because that's what I have right now. So we'll have area of the tall rectangle plus area of the long rectangle. If you see it the other way, try to do that, okay? Try to do it that way and see if you can get the same answer as I do. These 2 parts will be different because it's a different tall rectangle versus a long rectangle, but I challenge you to see if we can do it. Okay, so our tall rectangle, we have a little bit of math we need to do. We know both of these have the formula length times width. So this one, the long one, the way I drew it, the length times width is completely labeled, right? The length of this long one is 17 and the width is 3. So for this long one, I'm going to do 17 times 3. If you were someone that saw it this direction, the tall one's easily labeled 10 by 5, okay? So it depends which direction you saw it. Now this taller rectangle that I have has the width labeled a 5, but notice the whole side here was 10, but we don't want the whole side. So our question is, what is this length? How'd you do it?
Subtracted the 3.
You did. Perfect. So what she realized was this whole side was 10. So this whole side was 10, but if this was 3, so was that, correct? So this chunk took up 3 of the 10, right? This whole side's 10, and we know 3 of it, so what does that leave for the upper part? 7, right? So that's just 10 minus 3, or 7 miles, right? So we have it now, guys. Our length is 7, our width is 5. And we can do it. If you did it the other way, guys, you should have a 5 by 10 rectangle, and then you would do the same thing here. This whole length was 17, but 5 of it was taken up, so the length would be 12 times 3, okay? So however you see it, you are more than welcome to do it that way. So what do we have? 35, and then what's 17 times 3? 71? 51? Look at me not do mental math very well. And so that's going to be 86. Is that what you guys got? And again, that's a good example of maybe a yard where it wraps around the house or something like that. So the front page is purely examples of this shape and this shape. When we add them together, makes a new shape. But all you do is find the areas and add them together, and you have that area. On the back, if you don't have any questions on the front, guys, the back is more of, I have a total shape, like a bigger outside shape, but then I'm taking away a smaller shape. So if we're going to take away, we're going to not add, we're going to subtract, okay? So if you look at this, you could actually do it kind of like the one we just did, where if you wanted to close this off, you could have a rectangle and a rectangle. Or do some of you see that this could be just kind of like a rectangle missing a little chunk there? You guys agree? Like, it's this room, the area of this room. We have the cutout for the door, right? So if we're going to just carpet this room, we don't want to carpet that doorway, right? So one way to do it is just, okay, well, how long is this room? How wide is this room? And let's just figure out what the area of that little small chunk is and subtract it from the big area, okay? So this is going to be area of the big rectangle minus area of the small rectangle. And again, we'll have to do a little bit of finagling to figure out what the area is of that smaller guy, okay? So we have length times width minus length times width. The big rectangle is obvious. Do you guys see that this whole side is 25 centimeters and this whole width is 15? Are we okay with that? So that's the, and it might be equivalent to this. It could be 25 feet by 15 feet. That would be our room. So we're going to have 25 by 15 for the big one. Now the small one's a little bit harder because it's hard to see how they labeled it. This length is 5. So they told us the length. What we don't know is this itty bitty width. So the length is 5, and we don't know that itty bitty width, but it's exactly what Corey helped us out with on the other page, right? If this whole side is 15, and we know that is going to be, what would it say? This whole side is 12, right? What is that gap? What's the difference between 15 and 12?
3.
Just 3. So this is just 15, this whole side, minus 12, the shorter side, to get 3 centimeters. Okay, that is what this little gap is. So we know our width is 3 there. Right, so if this whole side's 15 and 12 of it's taken up, then we know that outside part of our hallway is 3 centimeters. All right, I do not have this. No, I do have it individually. So do you get 375 when you multiply and get the big area? Does that look right? And then 15. So I got a total area of 360 centimeters squared. Does that look right for those that are doing it on their calculator? Okay. Did you have to do it that way? No, you could have broken it up into 2 rectangles, a 20 by 15 rectangle and a 5 by 12. And that one actually is even an easier way to do it, I think, because we didn't have to do any finagling. We just knew we closed this off. So we had 25 across, but 5 of it was taken away, so that's 20. So 20 by 15, and then this was just 5 by 12. If you did it that way, you should still get 360. So don't think there's only one right way to do it. Say this is your pool, okay? You have a tiny little kid pool, I guess, or a water fountain or something. So say this is a water fountain and you put this decorative border around it and you want to fill in the triangles with rock. What kind of area do we need to fill in with rock? So what is the outside shape? The square, and what is the inside shape we want to get rid of? The circle, because we want to find the area of the shaded stuff, okay? So we're going to take the area of the square and subtract the area of the circle, and what remains, the difference, will be that those little triangles that we want to fill in. And notice they're not perfect triangles, so they are curved, so we do want to use this formula. All right, so if this square has a side of 2 feet, what's its other side? Since it's a square. All sides are 2 feet. So I'm just going to label this 2 feet. All right, so the area of a square is length times width. The area of a circle is pi r squared. All right, so we know our square is just 2 feet by 2 feet, right? So I'm just going to do length times width, or side by side, or base times height, however you want to do it, 2 by 2. So the square has a total of 4 feet squared, but we obviously are not filling in that much, right? We're actually filling in quite a bit less. So we don't want to go with the area of the square, we want to take away the area of the circle. So pi is going to hang out, but remember what your radius is. What's the definition of a radius? It's from your center out. It's not all the way across, right? So one thing we do not have labeled is the radius, but
Yeah, just make it 1.
It is just 1, right? Because if the whole side from here to here is 2, then the radius would just be half of that, right? This is just a radius of 1. Right? Remember, technically the side would be the diameter, okay? And half of the diameter gets you that radius. So we just took 2 and divided by 2, and we got 1. All right, let's do the math with exact and with approximate, okay? So exact means leave pi as pi. So here we have 2 times 2 is 4, minus pi times 1 squared, but what is 1 squared? 1, and what is pi? Pi. 1 times pi is just pi. So the exact answer, guys, is 4 minus pi feet squared. But if you go to the lawn center and say, oh, I need 4 minus pi square feet of gravel, they'll be like, what? So what we're going to do is we're going to use an approximation for pi, typically 3.14, okay? So this is the exact. So then we're going to do 4 minus 3.14, and do you guys just get 0.86 feet squared there for the approximate? And notice, guys, that's barely anything. That's not even 1 square foot of gravel that we need. So it's good that we kind of figured this out and we didn't go say, oh, well, my square is 4 square feet. I need that much gravel. No, you don't even need 1 full foot of gravel. Okay, it's kind of weird looking, but normally my math lab will probably want like one where you probably approximate it. All right, the next one's kind of interesting. Ideally, you would just say, okay, this is one triangle, this is one triangle, let's add them together. But when you find the area of a triangle, you need to know their bases. And right now we know their heights, 25, 25. And their total base is 25, but we don't know the individual bases. So that's not how we can do it. So what could we also see? Remember, this whole side is, think of the outside picture and minus an inside. So what could this picture be as far as the outside? What shape is it? A square, right? So let's go ahead and add this side. Okay. And do you guys agree if we take this whole square and subtract this triangle, we'll have the 2 triangles we want? You guys see that? So we're going to take this whole square and subtract this triangle right here. So we'll take minus this triangle, it's a little star in it so you know what triangle. So if we take this square and subtract the hollow, right, what we don't want, that will get you what you want. You're like, well, Molly, how does that help us? Because what is its base? Its base is the entire side, which is labeled 25. So we know its base versus these 2 separate bases we don't know, okay? So the area of a square is just length times width. The area of a triangle is 1/2 base times height. Remember, a square, really, you could do length times width, base times height, side by side. It doesn't matter. The 2 numbers you're multiplying are always the same, right? So this one is 25 by 25. Is that okay for the square? Okay. So we're going to find the area of this entire square, and we say, well, wait, we don't really want the area of that entire square. We want to get rid of this part. So let's find the area of this part and subtract it out. Okay. So we'll have 1/2. And really, if you do it this way, you can kind of see what's going on, right? Its base is technically this, but since it's an area of or since it's from a square, what is this base? 25, right? And notice the height. The height goes all the way across. So what is the height as well? 25, okay? So believe it or not, this triangle is taking up half of the area, okay? So we have 1/2 base times height, but we said this base goes all the way across, so it's just one side of the square, 25. And then its height goes all the way across. So it's 25 as well. This is not equals, that's a minus there. Okay, so 25 squared, I think gets you 625. So the second part is 625, but half of it, right? That square is taking up half of it, so half of 625 is 312.5. So when you subtract the 2, you should get 312.5 feet squared. The last one, guys, I want to kind of just do the first sentence, say, okay, what should we do, and then what should we subtract out? The reason why I don't want to stress about the actual formula is because the formula for a hexagon is actually quite difficult, and we're not actually ever going to see a hexagon. So it's just the concept I want you to see. Like, what is the outside shape and what is the inside shape, and how do we get the unknown that we want, okay? So looking at this last example, example 4, what is the outside shape? A circle. So we're going to take the area of the circle, and what's the inside shape? That hexagon. Because it's hard to tell, but guys, all these little chunks in here, these little moon-shaped chunks, are the shaded area that we're trying to find, okay? So we have this entire circle, the whole thing was shaded, but then we want to get rid of this hexagon. Good luck drawing a hexagon. Eek. Not too bad, okay? So what you do, like the formula, I can tell you what this is, but it's 3 cube root of 3 over 2 times a squared, where a is the length of a side. I'm not worried about that. So I just want you to get the concept that you have this entire shape, but we want to take away part of it, all right?